Greetings and felicitations. What I've got for you today is the cheapest power supply on Amazon. Yeah, there's other kinds of power supplies you can get for cheaper, but this is the cheapest of this type with the adjustable voltage and current fine in course. So this is the cheapest one. This was, I think it was $44 or $45. 30 volt, 5 amp. They also have a 10 amp version, considerably more expensive. It is model TP3005N, and of course, it's made in China. So let's get it out of here, have a look at it, see what we think of it, what makes it tick. We get some cabling, always nice. There's the instruction manual in there. Are we not men? Do we not discard instruction manuals until we need them? So, there we have the unit. So I looked in the manual, so sue me. Anyway, it says 8-hour Conti, continuous operating time, and it measures 85 by 160 by 205 millimeters. Yeah, I have no idea what those are in real measurements. Anyway, it uses a 3-pin IEC cable. So, get some light down here. First thing I'm going to do is test to make sure that it's grounded. It is. Well, that's interesting. The upper front pin is not giving me continuity. All the other screws on that side are. Screws on the back are. The back case itself is grounded. This is coated, so we're probably not going to get anything there. Interesting. My guess is, since this front panel is plastic, those screws are only going through the plastic. But, you know, what can we say? We'll see what it looks like when we open her up. So, I know you're saying, good God, Paul, don't you have enough power supplies? Well, yeah, I do. But one of my goals is to bring you low-cost equipment for your lab. So, see what kind of fuse is in here. If it will come out. Interesting. 2 fuses. We will check that out. Okay, so I've powered it up. The voltage and current controls are all the way down. And it's showing, 0 voltage, 0 current. Let's hook up a multimeter here and see what we get. Okay, from the 0 point, we get 0. Now, if I just increase the amperage, we're getting 24 millivolts. Okay. Now let's try the fine adjustment. See if we can get a... That's interesting. So that's showing us 1 volt. And I'm getting 0.958 millivolt, 958 millivolts. So at 900 millivolts showing, we get 935. Let's see if I can dial this down to 100 millivolts. Very hard to get the adjustments just right. It's very hard indeed. So, showing 100 millivolts, we're getting 119. Close, but you know, not super close. Let's take it up to a useful level of about 3.3 volts. And we're getting 3.37. Okay. Take it up to 5 volts. 5.014. 9 volts. I just want to see how accurate it is across the range. Of course, this is unloaded. The adjustments are very touchy. So at 9.05, I'll just take it all the way up. Go right at 30. 30.08. So definitely close enough within the ballpark, so to speak. Let's try it with a load on it. Okay, I've attached some banana plugs there in parallel, and I have here a 10 watt 10 ohm ceramic resistor that will attach. Should be around a half amp. We're seeing 5 volts out, 4.975. So within 25 millivolts, that is definitely acceptable. No problem there at all. Nice and warm. Next, we're going to try and set our current, which you actually have to have a load on it first to do. So I'm just going to short it out here. And what I want to see, it's about, let me get it down to around 20 milliamps. That's good. Then we'll set our voltage for about 3 volts. And we'll hook it up to this little selection of LEDs here. As you can see, they're nice and lit. That's 130 milliamps. That's more than I wanted. See if we can dial her down here. And it's not real accurate in these low current settings, but all in all, it's not too bad. So let's check the accuracy of this meter with an ammeter. Okay, so we got the meter K here, setup for our ammeter. And we'll hook it up like this. Positive to there. Negative to there. And when I touch this to here, our LED's light. And we're getting 40 milliamps there. And 52 milliamps there. So, not entirely fantastic. I mean, we're looking at a difference of 12 milliamps. Not a great deal, but if you're dealing with very sensitive stuff, it's enough to make a difference. Alright, removing these last couple of screws. They are all very tiny, maybe 2-3 millimeters. We'll take a look inside. I mean, this is obviously a switch mode power supply, which means it relies on the principles of an inductor and something switching the current on and off very quickly, generally a MOSFET. So yeah, okay, obviously here's our first thing. Those front screws weren't attached to anything whatsoever, so that's why we got no continuity on that case there, whereas all the other ones were attached to metal. So that's very good. Very good indeed. Alright, let's come down in here. Get my camera all nice and adjusted there. And we can take a closer look inside. Alright, so we have our we have our connections coming in here. Blue and brown. Not standard US color coding, so here it is from one side of the input. Here, I don't know how well you guys are going to be able to see this. Well, that's not good. From the other side, it comes down here with a little strap across that, what's the word I'm looking for? Fuse. Fuse is the word I'm looking for. And then we have our grounding attached very nicely there to the base. This little threaded doohickey here goes in here to hold the face on. You definitely don't want that floating around inside of here. So there's our, okay, so they're using brown as live and blue as neutral. So here's where they're coming on here. We have a nice suppression capacitor, 340 volt. A choke, another suppression capacitor. We've got three nice mauves here. There's PTC. And I'm betting, I can't really read it yet, but I'm betting that's our old friend, a 555 timer. Let me have a closer look. No, not a 555 timer. In fact, it is a TNY277PN, which is an AC to DC converter, 18.5 watts, 85 to 265 volt AC. So that is a just a strangely shaped bridge rectifier. Very interesting. Okay, next up we have this little daughter board here. And on it is an LM758, which is a dual op amp. Let's see what else we can see here. Transistor there. Polyester capacitor. Got a tuned inductor here. There's our current shunt, along with a 5 watt 470 ohm resistor, big smoothing capacitor, a couple big power resistors down here, transformer there. Now heck, now that looks like a diode package. I mean a bridge rectifier package. Let me have a look. Well, you can't see what I'm pointing at, can you? Right chair. Let me have a look at that. Hold on a second. Nope, I was wrong. That is a Sharp PC817, which is an optocoupler. So this definitely has an interesting topology going on here. As we take a little tour around the board. I don't see a switch mode chip anywhere in here, which is odd. But I'm sure there is one. There's our power output transformer there. Interesting indeed. Okay, for our final test, we are going to check out the ripple, because it says it is low ripple. So we'll see how that does. Okay. Let's set it. Let me turn here so you can actually see it. We'll set it for 12 volts, which is what we want here. And we will attach it to these LED light strips, which are super bright. Pow! Surprised that doesn't blotto out the camera. Okay, so you can see we are in constant voltage. That'll burn them up lickety-split. So we'll put about 13.5 volts. That gives us a little over 1 amp. And then I'm going to attach the oscilloscope right here at the output. And we'll go up here and have a look at her. Like, this thing just doesn't want to stay. Come on. Okay. So there we go. Let's go channel 1 coupling. We'll AC couple that. And then we will zoom in. Oh, yes indeed. Then we will measure voltage, channel 1, peak to peak. And we are getting, whoa, sorry about that, didn't mean to bump it. We are getting a peak to peak ripple of 50 millivolts. Once again, not terrible, but again, not great. So, what do you have to say? Well, I'll tell you what I'm going to say. For $50, you know, plus or minus $5, wherever it was, I think it's actually a decent little power supply. You know, the voltage was off by, I think, at most 12 millivolts, and the current was off by like, what, 10 milliamps. You know, it's not, we don't need to keep blinding money. We don't need to be that particular. Even in electronics, 10 milliamp, probably not going to kill you. I'm sure I'll receive many critiques for saying that. But that's the way the game goes, right? Right. Anyway, I like it. I give it a thumbs up. I'm going to put a link to it down below. And if you guys need a low-cost power supply, check out the Tech Power TP305N. This was not sent to me. I went searching for the lowest cost switch mode power supply I could find, and this was it. Alright, if you liked it, give me a thumbs up. Feel free to comment, share, and don't forget to subscribe. Big thanks to everybody. That's it. I'm out. Peace. Hola a todos mis amigos que hablan español. Si hay suficientes de ustedes, haré uno o dos videos en español.